Thank you, everyone. I'd like to introduce Haus from HPE.
All right, that was a quick intro.
That was very.
Thanks a lot. I lost 1 minute, right? Just so you time it right. I have a lot of material here, and if any of that needs further discussion, we'll be around. We have a booth. There's a preprint on archive that you can download on part of it, and the other stuff is on GitHub. So none of this is whatever corporate secret. I really want to get the idea out that we can build secure workloads end-to-end from your laptop here in the audience with a trusted entity somewhere else and an HPC system like Lumi or Isambard or whichever kind of HPC AI target you have, including proper modern HPC networking in there. And why I'm mentioning that network layer will become clear, I hope, at the end of the first section. So the first part really is something we did 2 or 3 years ago with the folks at Lumi. There's a simple request, and I wrote it down like a note paper, right? We want users to be able to run applications and make sure the access is protected in such a way that this job can only run in the end on a given system, say Lumi, not Mare Nostrum, even though both are your HPC, and not because one is NVIDIA and one is AMD, which maybe precludes some reuse, but even on simple identical hardware situations, and can only be executed on a designated subset of the compute nodes, which is a vague way of saying certain nodes that have qualifications like the firmware of the NIC is the following version. I don't trust any other. Or whatever your criteria are. Pick what you want, and let's see what the attestation layer for that would be. It's all open. And it can only be run once. No reruns, because you don't want people to do replay attacks on their secret underground copy of your machine that they might build with sufficient funds. Well, this is really putting it into a big picture, but that's part of the request, right? Run once, not multiple times, and cannot be inspected in transport or in the queue by the admin. Because usually if a job is in the queue and you're admin, you can see what people will be running and you can extract parts of it. And we want an audit trail on all of that. So that's a big ask. And that's the story I'm chasing for a number of years now. And if you're in HPC, then you'll probably doubt any of these items being easy or feasible. If you're a vendor of secure cloud options, you'll tick every box saying, yeah, we can do this, we can do this, we can do this, we can do that. The question is, who believes that, pays for it, how do you implement it? And I've personally not had experience with that. I'll trust you if you say my secure cloud solution does that, and I trust you more if it's air-gapped, right? So no, let's go back here. So first attempt, we containerize the application. That helps a bit in terms of shipping stuff around. We encrypt them, we encrypt the data. If we have an encrypted container of the application and we trust that layer, then inside we can have data access keys to access the data at runtime with encryption. So maybe that actually is a nice way of shielding things. We need an attestation definition of what is good enough. And that's where things start getting fragile. Then you need a per job key that is used once. So you need a vault handling that and attestation layer ensuring that the key is deleted when it's given out once, but that can be attested, can be audited. And then you want to decrypt the payload only after you attest the target resource as an enclave, and only then will the vault give out the key, and you need that logged, right? So that was our attempt how to do it. This is really part of such a larger situation, right? Where you want to define what is an attested HPC enclave, how do you manage keys on top of that? What does the service provider layer look like on top of that for a trusted research environment or for a simple HPC system with special needs for some customers? And how does that translate outwards, right? And distributed data is another part of it, and different computing environments are another one. So kind of the big picture. We did solve at least one part, which is the key lifecycle. And on the on this GitHub page at CSC, you can download all the components. That's all open source components, except you may need a license for HashiCorp Vault, which we didn't need back then, or you need a different Vault provider of your choice if you want to go free. So generate a key pair, make sure the keys are stored in a safe place. You have key access policies that match per job ingredients, which is the attestation definition in a language of your choice. Spiffy Spire was our choice of attestation layer. That's an open standard with an open implementation. Again, just one way to get it done. That enforces that at execution time. So it checks whether the firmware version is the one you wanted to, right? Or it checks whether the node is node 7, which for some reason is better than node 8. And then the next steps are as you would expect, right? So this is part of your Slurm prologue if you run Slurm. And then the node maybe checks that no login happens while you're running. Otherwise, it just crashes the node. So anybody logging in cannot inspect at the time that PAM says this node has a login possibility or not. So crash and burn kind of attempt to securing things if things should go wrong, part of the runtime. And then you need a bit of tooling around that to infect a given container with a data input, data output directory of well-known name. All of that is technicalities you can easily solve so that the user's results will be collected if they're in a certain directory on a temp disk on the nodes at runtime in RAM. They will be encrypted with the user's public key, so they can be shipped out as a bundle. Only the end user can read because it's their public key. And then you cleanse the node, again, in a way that is attested and audited in the right way. Fine here, right? If you don't do network, right? Because as soon as you go out over the network, what is your enclave, right? Now, if you're in the cloud space, you do VLANs and you hope you trust your VLANs, or you go separate equipment in a software-defined network infrastructure. In HPC, VLANs can be done, but we care about RDMA, which is typically not on VLANs. So that's where I want to go here. So there's a full state diagram of how attestation can work with the holes in there about what actually you attest, right? But attesting network is hard. So that's where we were. And we moved into that space on the Slingshot interconnect. Well, it's an HPE talk. That's the network I care about most at the moment. You can likely do the same with InfiniBand, of course. I don't know about the other competitors at the moment. It's really, I'm not trying to say this is how you need to do it in general, and Slingshot is better for this than others. I'm just saying we're solving a problem on Slingshot. If you have Slingshot, here's a solution coming up. The first challenge is we have in Slingshot what is called a virtual network identifiers. That is security realms for a job. All the nodes communicating about RDMA statements in one job need to share a VNI service. And these are tied to user IDs and group IDs traditionally, which is good enough. If you run a Slurm job and they run a Slurm job, then you can't be seeing your data on the network because that is shielded with a tag on the network. And you can do hard enforcement. So like on a VLAN separation, packets are dropped on the switch before they reach any other port if those ports don't share the same VNI. People typically don't do hard enforcement, but in this case, we would probably do that. Soft enforcement just means traffic is routed according to that, but with a sufficiently malicious attacker, they could probably still eavesdrop. But user ID and group ID is not good enough in workflows where, for example, Kubernetes runs with a Kubernetes runner ID that is the same for all jobs. The difference here is your workload ID, your Linux namespace on the node that is reserved for the components on multiple nodes of the pods that you run on each given node. So we need an extra handle to abstract the fact that a certain set of executable components, let's say pods distributed over multiple nodes in Kubernetes, share an identity and as such get a separate network identity, a VNI. And Kubernetes is also not aware of VNIs for obvious reasons because no one looked at that before. So the diagram that came up is pretty obvious if you've seen the components, but intimidating if you haven't. So the first thing is your kernel needs to be aware of some other property deciding membership of something, like say a job, a thread in a security realm. So small change to the Slingshot driver. That's 10 lines one evening done, if you're happy to change your Slingshot driver. Then there is support libraries, which need to be touched because they need to interact with a new structure. Fine, doable another evening or two. That's the part that just means network namespaces are similar to user IDs and group IDs at the Slingshot level. The next level is someone needs to configure that, and that's Kubernetes when they start a job, and there's an interface called Container Network Interface, CNI, where you need a sufficient plugin that runs these configuration jobs. That was a bit more work. And then finally, you need someone doing the bookkeeping on top of that, because you need to audit things and you need to release the VNIs that Kubernetes allocates in Kubernetes land. So that was part C. And so, yeah, I already mentioned that in Kubernetes land, on every node, Kubernetes allocates a network namespace, which you can see as a file in Linux. And a process can look at its own namespace, and other parts of the Linux system can look at the namespace of a job. In particular, the kernel can look at it. So if your job runs and the kernel is asked to do transport, open a device in particular for network RDMA, they can check which namespace you're in and whether that is enabled. Again, one if and a bit of glue. And that is useful because the namespaces are governed outside of the container, so users cannot change that. While inside a container, they can change their UID and things like that, right? But network namespaces are assigned outside of that, so each containerized workload has a predefined network namespace when you run it through Kubernetes, so it's a good handle, and is the classic isolation mechanism anyway. And so sharing that means you're trying to communicate in a good way and should be allowed, and others should not. Now, you need to have a small language. I don't know if you can read that, but we'll share the slides. So you need a bit of language in your YAML for the container resource definition. So we invented something that looks okay, essentially saying you can say a certain workload definition needs a VNI, yes or no. If you say that, then the plugin kicks in. And there's a subtlety. You may want to reuse such an allocation in a different part of that definition file. So there's a difference between a VNI itself or a VNI claim, but that's just management, right? So you can have multiple parts claiming to be using the VNI or asserting a claim because they belong to the same workflow, right? You can't, if everyone gets a new one, then you have too many. But if you have pieces that need to work together, one allocates it, the other claim. But that's just YAML, and then you have that. Now you need to manage that. There's a small controller with REST API that handles that. Easy to run. And then there's a unfortunate part, because this is a cluster paper that we presented 6 weeks ago, and it's all built on all the open source visible parts of the Slingshot ecosystem. So I'm an outsider in all of this, not an HPE person. So you can replicate it, right? But that brings the issue that there's no central management tool for VNI handling. So we had to build one. This is not great. It works on reasonably small systems, maybe scales to a few hundred nodes, a few thousand Kubernetes jobs per whatever minute, hour. But it's not the final solution for a production system. But it does what you think, right? Allocate, keep records, and deallocate these on a database. On a real HPE Cray system, you have a service called DRC2, which is already installed, that Slurm uses to do the same, and that's where we should be integrating, but that's not open source yet. So that's why it's not in here. It's the natural replacement for this VNI service you find on the paper. So here's some data, and that actually needs. We had someone yesterday saying you always should put your funders first. I put them in here where the actual test bed needs to be credited. That's the OpenCube test bed. If you want to talk about OpenCube with me, happy to do so. It's ARM nodes, Ampere ARM nodes. So reasonably interesting cloud architecture scale things, a bit less than a Grace, and then Kubernetes K3s, and we were trying to see whether doing this creates overhead you need to worry about, right? To comfort you, it's not bad. So on the left top, you see the bandwidth obtained, and it's just great. You don't see no difference between having VNIs enabled through this Kubernetes interface or not. Same line. And on the right, you see essentially the overhead for tiny packets. Yes, you notice that there's some communication with this VNI service, the container network interface, bringing up, bringing down things at namespace level when you start a job. But again, at whatever 8 kilobyte, it's essentially vanishing. Below that, if your communication is very low and your job does only this tiny bit, then there is overhead. But it's still in the 1% range. Latency, again, no major change. Again, on smaller messages, there is 1%, I mean, until a megabyte roughly. That's what we tested. But again, reasonable for the security that you gain and for the actual abstraction that you gain. And this is the most interesting one, I think, for high throughput, because Kubernetes sometimes is used to do high throughput. So we did a ramp up, ramp down test. What happens if we submit hundreds, I think this is 500 Kubernetes jobs at the same time, and you see some saturation of the admission. But again, that's the same whether you do VNI or not, right? So there's no kind of throttling effect that you cannot submit as many jobs in your high throughput scenario as you could before. So again, quite nice. And so yeah, we did that because this is an HPC AI thing. Where is that useful? We took an inference job, BERT, for being boring, but that was the simplest thing to fetch for 2 or 3 nodes because we don't have a large test system here. Where for an odd reason, we did run multiple BERT inference jobs lengthwise. So each job spread over multiple nodes because we can, splitting essentially layers over the nodes, but having the same node number 1, each job has some component on node number 1. And imagine you do that because on node number 1, you run the port forwarding for your query interface. That's the only one you need to expose to the outside network in some way. But then you have hundreds of nodes to spread your model out. And yes, you can criticize that. Why don't you run one BERT model on one node? But again, this is the setup we did. 1 minute, great. So end with a roadmap. If you're interested in this, we have a merge request on the internal HPE Slingshot host software 12.13. Let's see which one makes it into a release. So if you're a customer and you're waiting for that, ask your salesperson whether it's in, or ask me. I'll let you know as soon as it is there. All the patches are on that archive preprint and on the cluster paper reproducibility material. DRC2 integration is something we're going to do for the customers. And I hope DRC becomes open source. Spire integration end-to-end. Attesting that this is happening is just one extra test you need to do for the security. And node-level memory encryption is the piece I didn't talk about, which we also need, and that's hard on HPC nodes. So with that, I have about 5 seconds left for team advertisement. So EMEA Research Lab, we're doing projects with customers and non-customers. You want to do a project proposal, need a partner, talk to me all across Europe. Thank you for that.
Thank you.